All right, so we are starting off our first lesson in the 9 weeks with functions. We're going to start with our definition of function. Each input results in exactly one what? Okay, so this is just a reminder that input is talking about the domain. That's all the input values. If we're talking about on a graph or in a table, it's all the x values. For the outputs, it's always the range, and that's the y values. When we talk about an ordered pair, we pair a domain number with a range number, so that's going to be an x and a y. Okay, so one side of this paper is going to be talking about what looks like a function and what is not a function. Okay, so in this chart, this rectangle, put function. Okay, so now, this mapping diagram represents a function. If you notice, 1 maps to 5, 2 maps to 4, and 3 maps to 6. We can put this in an input-output table. Make sure your x values are on the top, that's your domain. Your y values are on the bottom, that's the range. You may want to make yourself a note that these are the x's and these are the y's. So you're going to put an input of 1 with an output of 5. An input of 2 with an output of 4, and 3 with an output of 6. We can take the information from the table or the mapping diagram and write them as ordered pairs. They still pair off the same way. 1 is paired with 5, 2 is paired with 4, and 3 is paired with 6. Whenever we're talking about something being a function, the input should never repeat. If it does repeat, then the output should still be the same. It's when they're different that it's not a function. Okay, so now we're going to graph that information because we can tell by looking at a graph if something's a function or not. First, we're going to need to label our x and y axis with its intervals. So this is going to be 1, 2, 3, 4, 5, and 6. 0 is understood here. And then vertically 1, 2, 3, 4, 5, and 6. All right, so the input of 1, output of 5, that's over 1, up 5, put a point. Over 2, up 4, put a point. And over 3, up 6, put another point. Notice that if you look at these vertically, there's only ever 1 point in each column. That's how you tell if it's a function. Okay, now we're going to look at the other column of information on this page, the other side. So this is all the information, what it would look like if it is not a function. First off, we have this mapping diagram where 1 is mapped to 5 and it's mapped to 6. Okay, so this is what makes it not a function. So you're going to want to heavily mark that one because that's the one where 1 has an output of 5 and 1 has an output of 6. That's 2 outputs. The definition of function is each input has 1 output. All right, now we're going to go ahead and look at what it looks like in a table. So 1 has an output of 5, 1 is also paired with 6, 2 is paired with 4, and 3 is paired with 6. It's not a function because of the inputs. It's okay that the 6's repeat. It's not okay that the x value of 1 repeats because 1 is not paired off with the same number each time. So also if you're looking at ordered pairs, 1 is 5, 1 is with 6, 2 is with 4, and 3 is with 6. This is not a function because of the 2 inputs that are the same. Okay, and finally we're going to graph these 4 points. Let's go ahead and label our x and y axis. So we've got over 1 up 5, over 1 up 6, 2, 4, 3, 6. Remember I said go from top to bottom. So if you start checking each column, this has a point twice. So this is what makes it not a function, because they are double stacked. If they're double stacked, it's not a function. Okay, so let's look at what it looks like on a line graph. So we're going to turn over to the back of this page, and we have 4 examples of 4 different graphs. Okay, for the sake of talking about these, we're going to label them A, B, C, and D. Okay, so graph A, we're just going to start by checking each column vertically. So if we draw a line here, does it ever touch the line that's graphed more than once? It would touch it here. Then if I draw my line, it would touch here. That's only once. It still passes the test. Still touches it once. We're talking about this, like stretched S. If I draw it down this line, it only touches it once here. If I draw it down this line, it touches once here. This line touches once here. This line touches once here. So there's nowhere that I can draw a vertical line and it's going to hit that line more than once. So this is a function. Okay, move over to graph C. Okay, so if we do the same thing with graph C, if I draw a line here, it works. It only touches it once. But if I draw a line here, what happens?
It double touches.
It double touches right here and right here. So this is not a function. So what do you think B is? B is a function. If you check it with the vertical lines, it's only ever going to touch it in one place each time. What about D?
No.
Yeah. It's not a function, because if I draw a line here, it's going to hit it twice. How many? It only has to fail it one time. So if I draw a graph, let's say this is our graph, and everything looks fine, but suddenly it does this number, well, it's going to fail it right here, isn't it? So that's not a function. All it has to do is fail it once, and it's not a function. Okay? This is called the vertical line test. I want you to double underline this. Okay, so whenever we're checking a graph from top to bottom to see whether it's a function or not, that's called the vertical line test.